Hey, ladies and gentlemen, let's continue on our 3D modeling adventure. So if we take a look here, we have a blueprint. This blueprint shows, it's just some kind of shelf. Don't worry about what it is as of right now. It's just kind of a simple shelf. So this shelf is made out of different pieces. So our goal is when we're making something, when we're designing something to solve a problem, is that we want to have a blueprint of it so then we can make it. We want a really nice blueprint that has very nice, precise, specific dimensions. So those dimensions need to be extremely accurate and so on. And it's going to be about, most of our objects are going to be made out of multiple pieces. So that means if we're 3D modeling multiple pieces, we're going to have to assemble those pieces together so we can create a nice blueprint like this. So here's an example of an assembly of the pieces. So this is an assembly file. And what I used is I used this assembly file to then create this blueprint. To make this assembly file, I had to have the parts done first. So I had these sides done. So here's the sides. I had to have the back and this shelf here. So I have these other parts. So this object is made out of 3 unique sized pieces. So our big goal with these next couple lessons is to learn how to actually put these pieces together to create an actual assembly file. Here are some of the different things we'll be learning about assembling and constraining with our 3D modeling. There are kind of typical questions: what, why, when, how. Some important notes about saving. Important word is constraining. We'll figure out what that means and then the different types of constraints. Offsetting is something that's important when we're constraining. Using the browser, we've done that before, we're going to do it again. And then just other kind of miscellaneous type information. So assembling parts, another way we can say that is constraining parts. If you think of the word constrain, that means like holding down or constraining. Like if your arm is constrained, that means your arm is like held down. So what's happening in our program is this piece is being held down and stuck to, let's say, this piece and that piece. They're constrained together. So we're going to have to do that in our computer. And what's really, really important, what I need you to do is to really not only like go through and do these different constraints to get your stuff stuck together, but to understand why. Why do we actually do this, and then what's going on with the computer in terms of how is this actually happening. And that all comes down to, again, our X, Y, and Z planes. We've talked about these before, X, Y, and Z. And we have a rhyme. It's a very, very important rhyme. X, Y, Z, constrain all 3. Extra bonus points to you if you say that out loud right now. If you pause this and you say that out loud right now, super cheesy with a smile. X, Y, Z, constrain all 3. Do it, try it. People will look at you like you're crazy. So this rhyme is similar to a rhyme that we had earlier called XYZ dimension all 3, because in our program uses those 3 coordinate planes. That's why we call it 3D, 3 dimensions. So the same thing for when we're constraining or assembling. If we want a piece to stick somewhere, we have to tell the computer in each dimension where we want that piece to be stuck. So if we're telling this Lego head to go down right here, we have to tell that Lego head, okay, we want you this far down in the Z plane. We want you this far over in the X. We want you this far over in the Y. So that means we're giving dimensions or coordinates for each 3. The same thing, let's say, with the chest down to this middle section. So we're going to tell it 3 coordinate planes. I did that on my pieces here. So on this piece right here, I got my coordinate planes here. I had to tell it how far up and down in the Y. I had to tell it how far left and right in the X. I had to tell it how far in and out in the Z. So you're going to have to constrain all 3 coordinate planes. X, Y, Z, constrain all 3. So in terms of what is assembling, what is constraining, that kind of already explained. It's just keeping those parts. So in our 3D modeling program, it's telling those parts to stick together where we want them to stick together and how we want them to stick together. Why do it? Kind of already explained that a little bit too. To add to that, well, we do it so we have the parts exactly where we want them, so it's nice and precise. And especially if we're making something out of wood or something that's more complex, when we assemble it together, we can actually see like, hey, did I have the right measurement for this piece, or is there actually a little gap there because my measurements were not right? So when we assemble pieces together, it's very, very good to tell us, is our product going to be like, is it going to actually fit together? Is it going to work how we expect? And actually later on, if you get more in depth with our 3D modeling program, after you assemble stuff, you can actually like stress test it and so on. And there's just neat simulations we can do. So when to do assembling? In general, you really want to do the assembly once you're done making your parts. So if your product is made out of, let's say, 3 parts, so make those 3 parts and then assemble. If your product's made out of 10 parts, well then maybe once you're done with those 10, then start assembling. But you know, depending on what you're doing, once you get further on in your 3D modeling skills, you can kind of figure out when should you start assembling stuff. You can possibly do it even earlier on. One thing to point out is, now I've been talking about, okay, let's assemble parts, but also we can actually assemble assemblies. So that's just another thing I want you to keep in mind is, let's say for some reason I wanted to stick this whole assembly together on another one, is that I could like basically copy this and plop it together, and then I could have 2 of them stuck on each other. So you can assemble assemblies, not just parts. So how to do it, I'll get to that in the next lesson. The how to do it, just to explain something very quickly, would be just make sure you're constraining every single one of these axes. Now let's say, so I'm in a little test for you here. Let's say I constrain the x-axis and I constrain the y-axis. According to my coordinate plane, which way will the object move? Because if I miss the constraint, so if I miss the axis, the object is going to move in that axis. So if I constrain the x and I can constrain the y, which way would this object move? So if I did the x and I did the y, the object would move up and down according to a coordinate plane and move in the z, which right now is up and down. So let's try this again. So let's try that one more time, and let me try and explain it again. So when I'm 3D modeling, and I'm assembling parts, I really need to assemble in those 3 different axes. Almost every time, you always need to assemble in all 3 axes, or constrain in all 3 axes. Sometimes you don't have to. I'm not going to get into that right now. But let's say I have a flat object, I constrain it in the x, I constrain it in the z. So then which way will it move? So I got the x, I got the z, and kind of think about it, or move your hand or whatever, which way would this piece move because I accidentally missed the constraint. So according to what I said, I constrain the x, I constrain the z, I missed the y. So it's going to move in the y-axis because I did not tell the computer where it needs to be in the y-axis. So let's say I constrain it in the y, bam! Now that baby is locked in. I can't move it unless I go in my browser and adjust stuff, but we'll get to that in a different time. In regards to saving is very, very important, and this program is very, very picky. So if you're using Autodesk Inventor, it's very, very picky with how you save stuff. So here's my assembly file. And what this assembly file is doing is it's looking for these part files. So it's looking for these part files. It's using those part files. So what's very important is I save this assembly file wherever I have my part file. So if I go to Save As, now if you notice, I created a folder. I have a folder called Autodesk Files. And then here's my shelf folder. In this folder, I would have all those parts. So these 3 part files would be in here. Right now they're not showing up because it's only looking at assembly files, but there, now you can see them. So here's my 3 part files. So it's really, really smart idea to save. You got to keep it in the same spot because that assembly file, this assembly file is looking for those part files. That is all I really want to mention for this first lesson. We're going to move on in the next one and get into the actual constraining and show you what it looks like on the computer.